Welcome back everyone to Wes Explains Best. I wanted to do a part 2 of this Kuta software worksheet tutorial on factoring with the greatest common factor. In the first video we did this first worksheet which had a lot of non-complicated. We didn't have a lot of variables with the greatest common factor, so I wanted to do another one where there's more variables. So anytime you encounter problems with a lot of variables and common factors with variables and coefficients, that'd be a little bit easier for you. So let's go ahead and get started. When I look at problems like these, what I first looked at always is the numerical coefficient in front. So what I'm doing here is I'm looking for the greatest common factor between 9 and 6. Now you don't have to list it like this every time. If you can think of it right off the get-go of what the greatest common factor is, you can go ahead and just write it. But I'm just going to show you the process of finding the greatest common factor. So we know 3 and 9 go into 9, and we know 2, 3, and 6 go into 6. So if we're looking here at our greatest common factor, clearly it's 3. So with our numerical coefficient, we're going to factor out a 3. Now, that's not it. We're not done. We also need to look at the variable. So let me get this pink out. So now we're looking at the variable, and we notice we have a p cubed and we have a p. Anytime you're looking for the greatest common factor with variables and they have the same base as they do here, you're going to use the p with the smallest exponent as the greatest common factor. So we're going to use p, or p to the first, however you want to think of it. Now, why do we use the variable with the smallest exponent? Because it is a factor, and it's inherently a factor of the other one. So if we're listing factors here, we know that p squared, and p cubed are all factors of p cubed. Why? Because p times p squared equals p cubed. Let me show you this. I'm pointing, but you guys can't see me point. P squared times p to the first equals p cubed, and then p cubed times p to the 0 equals p cubed. What are the common factors? What are the factors of p? Well, just p. So if we're looking here, it's always going to be the smallest factor of p, or p to the first, between the two variables. The smallest exponent is going to be your greatest common factor. So now we're going to put our parentheses, and then we're going to divide each of these terms inside by the greatest common factor. That's divide, and then we're going to put that answer here. Now, right from the get-go, I can put a subtraction sign in between. I don't like that. Let me use a different color. I can put a subtraction sign in between because I'm just going to copy down what's there. Unless I factor out a negative out in the front, this is going to stay exactly the same. Since I didn't factor out a negative, this and this need to stay the same. Okay. Kind of made a mess here, but I hope you can follow along. Let me erase a little bit, actually. There, maybe make it a little bit cleaner. Okay. Now what I'm going to do is I'm going to take 9p cubed divided by 3p, and I'm going to put that answer here. I'm going to change the color, and then I'm going to do 6p. Technically it's a negative 6p, but I already copied down the negative. 6p divided by 3p. I'm going to put that answer there. Okay. Let's start with the one on the left. We can cancel the 9 with a 3. We can cancel one of the p's with one of those, leaving 2. So our answer here is going to be 3p squared. Then we have, forgot, blue is my cancel color. Then we have 2, the p's cancel, and I'm just left with green. I'm just left with 2. So my final answer, this is the factored form, is 3p times the quantity 3p squared minus 2. I'm going to show you another way to think about factoring, so let's pick another problem to do. This one should be pretty quick, so I'll go ahead and do this one. First, we're looking at the numerical coefficients, 2 and 2. Clearly, the greatest common factor is going to be 2. Next up, I look at my variables. Let's go ahead and use blue this time. Oops, my 2 got a little messed up. There we go. So we're looking at x to the 5th and x to the 4th. We're always going to use the smaller of the two. So we're going to use x to the 4th. Now we need to put our parentheses. Okay, now this is what I was talking about when I said I'm going to use it a little bit different. So you can divide this divided by the GCF and write it here. You can do the same thing here. You're going to divide by the GCF and you're going to write it in the second spot. You're going to copy the plus because this is plus in between, and you did not factor out a negative, so it's going to stay the same. Or you can think of it this way. I'm going to erase this. Hopefully you guys remember it. If you want to go back and pause, that's what I'd recommend, but I'm going to erase it. What I like to do is I simply say to myself, okay, what do I multiply 2x to the fourth by times mystery, let me make that a question mark, times something, question mark, equals 2x to the fifth. So that's a little bit easier for me to think of because then I know that it's going to be x. 2 to the fourth times, that was a terrible question mark, times x gives me 2x to the fifth. So I know x goes there. Then I think, okay, let me change my colors here. Purple. 2x fourth times something, 2x fourth times question mark, that's a better one, equals 2x to the fourth. Well, that's clearly 1. So I know 2x to the fourth times, well, let me just erase it, times 1 gives me 2x to the fourth. So I'm going to write a 1 there. And that's my final answer. That's one way to do these problems. So whatever you like, if you like dividing, like I showed here, if you like just figuring out what the number, the GCF, what number you need to multiply it or what term you need to multiply it to get these terms here, that works too, okay? Let's go ahead and jump to a more complicated one. Let's use one with three factors. Ooh, here, this looks like a tough problem. Let's go ahead and do number 13. Okay, first thing I'm going to do is I look at the numerical coefficients. We have 56, we have 70, and we have 49. If you want, you could list 56, 70, and 49 and list all the different factors. But what I'm going to do is here, I'm going to be smart about it. I know 49 only has factors of 7 and 7, or well, 7 times 7. So 7 and 49 are the only factors of 49. So I know that 49 is off the table. 49 doesn't go into 56, but I know 7 does. So I think I'm going to be working with 7. Now, it's possible that these numerical coefficients do not have something in common between the three of them. And if that's the case, you can't factor anything out. For example, if you were to have like a 2x squared plus 3x plus 7, these do not have anything in common. Therefore, you're not going to be factoring out a coefficient. Okay, so that's just a heads up on that, but we can look and see, does 7 have factors with any of these? And the answer is yes, it does. Okay, 7 goes into 56 8 times, 7 goes into 70 10 times, and 7 goes into 49 7 times. So we can factor out a numerical coefficient. Let's look at the variables now. We have n to the 6th, n to the 3rd, and n squared. We're always going to use the smallest of the variables, the smallest exponent of the variables, because it is going to be a factor of the other ones. Now we're going to put our parentheses, and we can start. Again, if you want to do for the inside of the parentheses, if you want to do 56 n to the 6th divided by your greatest common factor, 7n squared, you can do that and put that there. Or you can do what I like to do, and I just think to myself the following. 7n squared times what gives me 56 n to the 6th power? And that is 8, because 7 times 8 gives me 56, and then n to the 4th, because I'm adding exponents when you multiply like bases, and so there I go. I have a plus here, and because I didn't factor out a negative, it's going to stay plus. So now I think to myself, let's change color, let's do this pink. 7n squared times something, it's going to be a plus because it's plus, times something gives me 70n cubed. Well, it's going to be 10 because 7 times 10 gives me 70. And then it's going to be n to the 1st, or just n, because n squared times n gives me n cubed. So now I'm done with my second one, because I'm thinking what times 7n squared gives me 70n cubed, and that is 10n. Last color, let's go orange. So 70n squared, what do I multiply to get 49n squared? Well, 7 times 7 gives me 49. I carry the plus because it's plus here. 7 times 7, 7 times 7 is 49. N squared times 1 gives me n squared. I don't need to write times 1. That would be a little bit nonsensical. So that is just my answer. And I'm going to circle this. And that is my final answer. So I did 3 problems. Hopefully this gives you a little bit more clarity on how we factor. Ooh, heads up, if you have multiple variables, you need to do the same thing. You know what? We should probably do this. I'm going to do this one real fast just so you can see an example. I might do the even. Let's see. No, I'll do this one. Okay, so if there's... sorry for giving you a false start, but I really want to make sure, just in case you are confused on this one, this one's a little bit different. So first we're looking at the greatest common factor of the coefficients, and I know it's going to be 8, or it might be 12. Nope, 12 doesn't go into 64. Does any 12, 8? Nope, so it's going to be 8. So I factor out an 8. Now I treat each variable differently, so I'm looking at the x's. Because all three have x's, I'm going to choose the lowest exponent, x to the first. And now I have a y, so I have y to the third, y to the fifth, y squared, and y, so I'm going to choose y. So this is my greatest common factor. I make my parentheses. Okay. Now I think to myself, 8xy times something gives me 24xy. What is that something? It is 3. And I don't need to multiply any x's. X times 1 is going to give me x, but I need to multiply by y to the fourth. Y times y to the fourth will give me y to the fifth power. Got my first one. Minus. Let's change color. Let's go this pink. Now I think, okay, 8 times what gives me 8xy times what gives me 80x cubed y squared. Well, that's going to be 10. And then I have x squared, because x times x squared gives me x cubed. Then I think y times what gives me y squared, then that's going to be y. So I got the middle term. Now I'm on to the last term. Let me use dark blue. Okay, so now I have 8xy times what gives me 64x squared y. It's going to be plus because this guy is plus. And then I have 8x times x gives me x squared, and then y times 1 gives me y. I don't need to write it, and there's my answer. So if you have more than one variables, it's the same process, you just add another variable. Now I'm done. Hope you found this helpful, and I'll see you next time on Wes Explains Best.